This video is going to be about using the proportional directional control valve on the motion terminal, VTEM. You can see that right now I'm already on the web visualization for the VTEM. This is a web visualization that you can access through your standard web browser, Google Chrome or something like that. I'm using Google Chrome right now, and as you can see, I have 4 valves and 2 input modules on the far right. Actually, if we take a look at the actual hardware, this is how it looks like. So you can see here on the top, I have my motion terminal valves. So I have 4 valves, 1, 2, 3, and 4, and then the 2 modules that I mentioned. I have many pneumatic devices here that you don't have to worry about. We're actually going to be focusing just on this actuator at the very bottom, which has a spring there to also show force control as well. But anyways, we're not going to go too in-depth in that. I just wanted to show you the overall hardware that you can see there. Let's go back to the web visualization. So the first thing that I'm going to show you is the controlling this motion app inside of the web visualization. So once I'm in here, I'm just going to log in, and the password is VTEM, all lowercase. This is the default password that you can find in the user manual. I log in, and then I'm gonna take the right permissions from the PLC. Right now, I do have a PLC running, but it's not taking over control over this valve. And what I'm gonna do is right now, this motion app, the number 2 proportional directional control valve, is already assigned. I mean, what I can do, this is how it will look like if you didn't have it assigned already, right? So it just looks empty. What I'm going to do is you just select whichever you want, right? So if I want this motion app or this motion app, whatever, you can just select it and then assign it. How do you know which motion apps you can use? Well, if I close this, here are the licenses that are available in my motion terminal, right? So this depends on which licenses are installed on your motion terminal. Anyways, I'm going to click again on that valve, and then I'm going to select the one that we're going to be talking about today, proportional directional control valve, and then assign. So now this is in there, right? And um, I'm not going to change anything here for now. I'm just going to go directly into test mode, and here we're going to select this option, which is a 4-3 valve, as you can see, just the valve that I can control. So I can control the flow on both ports, so port 2 and port 4. I also have the option of having 2 3-3 valves. Doesn't matter in this case, we're just going to use the 4-3. And the next thing that I have here is I can control the current behavior of the app, right? So right now both ports are blocked. Anyways, I'm gonna start the test run, and you can see I scroll up and this valve is already running, so that's good. And this is what I want to show you. So I'm going to activate both ports, and then you see that immediately I get some movement. So let me switch. Let me switch over here so you can see. So there, I switch over there, and I'm gonna move. I'm gonna move the on the web visualization. I'm gonna move the value. Let me see if I can bring that in here. Hold on a second. So let me bring this one, copy, and then let's just paste this one here. There we go. So now you can see the actuator. Okay, perfect. So now I want you to see that when I start playing with this slider here, you get some movement on the actuator, right? So you get some movement depending on if I go on the positive value, it retracts. If I go in the negative value, it extends, right? Now, if I do this faster, so if I go all the way on the positive value, it'll go faster, like that, right? So it's just using the full flow. Now, I can do the same thing over here. Oops, I can do the same thing here. You see? So the more aggressive that I do this, the faster it's gonna go, right? So now I'm just gonna do it like this. Okay, if I put it, so if it's moving, let's say I set it to minus 0.5, and then I can hear the air right now. Some air is going in there, but let's say -1. It should start moving soon. There we go. So now I'm gonna set it to 0. and the actuator moves, because basically what I'm doing is I'm setting that valve to the mid position, right? So now both ports are blocked. Okay, anyways, that's the basic functionality of this motion app. The one thing that I wanted to show you here today is using this motion app with um, with a PLC, right? So I'm just gonna exit here and deselect this, take write permissions from PLC. So this way now the PLC can take over. Um, so let's do that now. How am I gonna do that? Well, what I'm gonna do is I'm gonna jump into codices. I already have a program here open. Um, Here we go. So this is my codices program, and as you can see, this is my only program on my codices controller. By the way, where is my codices controller? Where it is running in the same motion terminal. So I have a CPX module on the far left. Let me show you that so it's not confusing. Where is this thing? Here. Okay, transition. So I have a CPX module over here. You can see right here, right? So you can see the CPX module. That's my PLC. Okay. So, anyways, let's go back here to code assist. And so what's going on here? Let me log out. What's going on here is I'm using this function block that's called valve control, right? And this valve control is the main function block that you use to control the valves on the motion terminal. You can read the manual, of course, for this particular function block. Key things is that you have to map the inputs and outputs that are specific to that valve. There's an enable bit for enabling the function block. Here you set the valve mode. So what is this valve mode? You might be wondering at this point. This, sorry, did I say valve? Yeah, valve mode. So valve mode is the, let me hide this. Um, There. So valve mode is the motion app number. So here you can see this is motion app number 2. So actually you can see it here. Motion app number 2 right here. Um, and basically that way I can know which motion app I'm running, right? So this would be motion app 6, motion app 7, motion app 8, and so on. Now let's go back to code assist then. So now you know where that 2 came from. Right? So that's that too. And then here I just declared a variable of type byte, which is control, and this allows me to select what am I going to be doing. So if I show you this here, this is a user manual from Festo. Um, in this user manual, you can see what I'm talking about. So I was saying valve control, yeah, app control, right? So app control, it has 4 values, 0, 1, 2, and 3, and depending on the value that I put there, are the ports active or inactive, right? So remember when I stopped the actuator and it wasn't moving anymore, I set it to 0, right? So this means that here, as you can see, actually, let me bring this over here. As you can see, when the value is 0, both ports are inactive, okay? When the value is 3 on the app control, then both ports are active. So technically what we're going to be using is just a value of either 0 or 3, right? And then there was another, in codices here, there was another variable, which was what? App option, right? So app option is nothing more than this over here. So you remember when I was in the web visualization that I told you, oh, I'm going to use a 4-3 valve. I could also do a 2-3-3s. This is how you select it on the PLC. Anyways, so I'm just going to use the number 14 there. So I can set this as a constant, right, over here in codices. So that's why I have a number 14. And then I have a manual acknowledge here. So in case that there's any error, I can just toggle this bit ACK or acknowledge, and I can get rid of that error. Now, the interesting thing here is that with this motion app, if we look at this user manual, over here, we can see that when we're using option 14, which is the 4-3 valve, so in option 14, this is the variable that allows us to, you know how I was playing with that slider, going left and right, left and right. So you have a value, that slider, if I move it all the way to the left, it would be a value of minus 10,000. If I move it all the way to the right, it will be a value of positive 10,000. And that's why, and that's how you can control the position, or the how, yeah, the which port is open or closed, right? Okay, so set point value 1. It set point value 2, we're not using it because this is not used on valve type number 14. Again, 14 comes from here. Okay. All right, perfect. So let's go back to codices. Now, because I know that I need to set the set point value to something, what I did here, just to visualize how this will look like with, I don't know, for example, a sine wave or a sine signal, um, sinusoidal signal. I'm using this generator, sin generator, or sinusoidal. This is included in a library from OSCAT. This is a company in Germany, I believe, that you can that they created a library, an extensive library actually. They have good things here. Um, and inside of this library, they have these signal generators. So I grab this gen sin, and this allows me to generate a sinusoidal signal, right? Um, how does this work? Well, oh, I wasn't showing you any of what I was talking about. So let me go over that really quickly again. I'm using this function block to generate the sinusoidal signal. This is included in this library from OSCAT, which I have here in my library repository, and you can find it here under POUs, engineering, signal generators, and here. So you can see the different options here, or the different variables here. Okay, sorry about that. Now, if you want to know more about, okay, what is included in there, let's take a look here. Uh, PDF manuals, and there we go. This is a manual for that function block. So here you can see that you have the period time. So in my case, I think I'm doing it at 10 seconds or something like that. We'll double check once we go back to codices. Then you have the amplitude. You can also specify an offset, and you can also specify a delay. Now, on the output, this is the analog output that you get. This is a real value, and you can use it for whatever you want. This is where you would get that sinusoidal signal. Okay, so let's go back to codices here. So now we're going back to codices. And remember that I told you that this output is a real value. So I'm not able to connect it directly into this input here, because this is of type int, as you can see there. By the first letter there, it says I. So this is of type int, right? So what I have to do is I'm just using a converter here from real to int. So I grab this value here, I put it in here, and then I send it to the set point value. Okay, so I don't want to confuse you further. I want to show you what this looks like, right? So now this program is running, and what you can see is that there's some values going on here, right? So it's going from a certain value. Actually, we can see here, let's see. So the uh, where is this? So my amplitude is of 10,000, and my the period is of 10 seconds, right? I don't know if these are the current values that are running there. No, I changed this online, so it's 2.5 seconds, and the amplitude is 1,000. Anyways, let's see how this looks like. So if I go to the trace, you can see that I'm tracing here that signal. It's nothing crazy. It's just I'm generating a signal, a sinusoidal signal. And the reason why I'm doing this is because I wanted to show the concept of having this wired, or yeah, I guess connected directly into the motion terminal. So let's have a look and see how that will look like once I run this sinusoidal signal, right? So let me go back to my program here. And what I'm going to do is I'm going to enable. So remember this bit, I have to make it true. So now the function block runs. So now the function block is running, but how come I don't have any movement on the actuator? You can see the actuator there on your screen. The reason why I don't have any movement is because remember that we haven't changed this app control. So where is it? Control. Remember that this should be set to what? 3, right? Let's take a look. So if we look at the manual, you see the app control. Remember that little table that I was showing you earlier? If I have it set to 0, which is the case right now, both ports are closed. As soon as I set it to 3, both ports are going to be open. Okay, so let's go back to code assist, and I'm going to set this control to 3. I'm going to write values. So now you're going to see the actuator starts moving with that sinusoidal fashion, right? So let me open that trace. So you can see, maybe if we close it like this, you can see that, okay, once it goes up, it retracts, it goes down, it extends, I believe, right? So we can start playing with these values and see how that affects the performance of the actuator, right? So if I change the amplitude, for instance, let's say I make it 2000, you see? So now it goes all the way forward, all the way back, and it's just gonna keep doing that. So we look at this trace, we can see the change there between the 1000 and 2000. Okay, let's decrease this to 500 instead of 1000. So now it barely touches the spring. Oh, actually, it doesn't even touches it. Let's bump it up to, I don't know, 1250. So now it's going all the way in, but not all the way out. You can see it's reaching maybe around here. It's not touching the end position. Let's close this to 1000, actually 850. So you can play with these values, but my point here is that this allows you to have greater control over the actuator, over a pneumatic actuator, because I mean, if you look at this actuator, I'm just using the valve there, but I don't have anything here, like any special flow controls or anything like that. So this would allow you to have good control over a system that will require this kind of motion, right? I can play also with the period. So right now it's 2.5 seconds. Let's set it to 5,000 milliseconds. So now it's going to take 5 seconds, right, to open the trace. So now the period is the period between the ups and downs, the positive and negative values. It's bigger because I set it to, what was it? 5 seconds. Set it to 1500 milliseconds. Right? So it will look something like that. Um, Anyways, if I wanted to stop this, for example, let's say I wanted to stop this while it was compressing that spring, how would I do that? I would just set this to 0, which is the control. So I'm going to write that as soon as it's compressing. And now it's going to hold that position um, because I closed both ports, right? So that's why it does that. Um, Now, this really has tons of applications, right? So imagine, I mean, the one that I'm thinking of right now is, imagine that I will wire this analog signal to, let's say, a joystick. So I could have a joystick, and then I could move left, I could move right, and so on, right? The other thing is, what if I add a sensor here, so a full stroke sensor. I don't have a bigger one here, but I have this little one here. So this is another actuator. But imagine that I have this kind of sensor that goes through the full stroke. I could close the loop now. Oops, I could close the loop now and do some positioning tasks. So actually, we have a motion app for that, but that's not the point of today's video. Anyways, that was just a quick explanation of how this would look like if we were to use sinusoidal signal with the motion terminal. And I hope you find it helpful, and that maybe you have an application for these kind of products. Thank you for watching.